Now, after the discovery of protons, electrons, and neutrons, there was the challenge of having the distribution of these particles, how the particles are distributed in an atom. And so, many attempts were made in this connection, and first was the Thomson's atomic model. Actually, there was a scientist named J.J. Thomson. J.J. Thomson. So, Thomson was the first person to propose the atomic model, and it is called as Thomson's atomic model. And you have read in junior classes, it is also called as Plum pudding model. Actually, Plum pudding model was not based on any experimental facts. It was just based on some imagination and arbitrariness. Actually, Thomson said that atom is a ball-like structure. Atom is a ball-like structure which is positively charged, and negatively charged particles, they are scattered throughout, just embedded. So he proposed that atom is positively ball. This is positively charged sphere. Positively charged sphere, just like a football, and the negatively charged particles are scattered here and there, just like this. So he said it as plum pudding model. So this is the distribution. These are the negatively charged particles. And one point was there that it was established by the discovery of electrons and protons that atom is electrically neutral, and so it is there. Actually, this model was unable to provide any scientific validity, or unable to provide any valid reason behind the distribution of the electrons and protons, actually how they are arranged, and so this model was not able to get any momentum, and so this model was failed. So after the rejection of Thomson's plum pudding model, there was a scientist named Rutherford, Ernest E. Rutherford. So Rutherford performed an experiment called as a scattering experiment, and actually the Thomson's model was failed because he was not having any scientific evidence that how the electrons and the protons, they are distributed in an atom. So it was the Rutherford who proposed, and the experiment was a scattering experiment. A scattering experiment. So he performed a scattering experiment, and he had taken a lead block. Till now, the radioactivity was known, alpha rays, gamma rays, beta rays, they were known. So he had taken a lead block, and it was established by now that lead can absorb the radiations, and it allows in only one direction. So similarly, there was lead block, and there was hole inside, and here there was a small amount of polonium. Again, it was very much similar with the radioactivity. So it was polonium. Now in front of polonium, he placed a lead plate or lead slit. Lead plate or lead slit means a thick plate having a small hole, which allows the alpha rays. Actually, polonium emits alpha rays, and so this is also called as alpha rays scattering experiment. A scattering experiment or alpha ray scattering experiment. So polonium undergoes disintegration. Polonium or any radioactive element, it is highly unstable and it disintegrates to emit alpha rays, beta rays and gamma rays. So polonium emits alpha rays, and alpha rays are nothing but the helium nucleus having 2 unit positive charge. Now coming main to our point. So the lead plate with a hole is called lead slate, and the purpose was to concentrate the alpha ray beam, alpha ray into a fine beam. So here see, this is nothing but this is alpha ray beam. Then in front of this there was a very thin gold foil, less than a millimeter was placed here. Why gold was taken? Because of 2 reasons. One is that gold is highly stable, and gold can be beaten into very thin sheet, very thin plate due to its malleability. And around this there was a screen. There was a paper screen, hard paper screen, and it was coated with zinc sulfide internally. So there was zinc sulfide layer from inside, and this is hard paper screen. Now, when any particle strikes to some material, then it is bifurcated. It undergoes distribution. It is scattered because of the presence of particles. So it was established that everything is made up of atoms and molecules. So there was the fine beam of alpha rays, and the atoms were inside the gold foil, and there was as a result a scattering of the alpha rays. Alpha rays were scattered like this, and here there was the scattering. And see, these were scattered alpha rays. These were scattered alpha rays. But they were scattered. They were scattered by the particles present in the gold foil. Now, Rutherford made following observation, as it is clear that observations were there were 3 observations. First was that most of the alpha rays were able to pass undeflected in a straight line. See, large number of alpha rays were passed in a straight line without much less deflection, and so we can put here. Now, second is some alpha rays were deflected to certain angles. These were deflected by certain angles or some angles. Now, third point was rarely 1 in 20,000 was bounced back to original path. So 1 in 20,000, like this here. So repeat again, most of the alpha rays were passed in a straight line without having any larger deflection, or the deflections were minor. Now some alpha rays were deflected to certain angles, a few were deflected to certain angles, and third, rarely 1 in 20,000 was bounced back to original path. So see, this is the original path, and so it was bounced back. This is the first part. Now, other point, that why zinc sulfide has been taken, a zinc sulfide layer is inside the hard paper screen. It is because zinc sulfide has a special property, and it is called as fluorescent nature. It is called as fluorescent nature. So zinc sulfide, when any alpha rays they strike against the zinc sulfide, there was the production of little scintillations. Scintillations means the twinkling of stars. So, as you know, twinkling of stars is for the stars only, but scintillations is for the minute particles. So, when very tiny particles they are produced, tiny light particle is produced, and so these are called as this scintillation. So, zinc sulfide, it glows for very small time period. Like children, you all must be knowing, we have the tube lights in our homes, and so you might be knowing that inside the tube there is a white powder. So white powder is nothing but this white powder is basically zinc sulfide, and it is tube light is actually cathode tube, and so there is the emission of electrons in the tube light by its own circuit, and actually the electrons they strike against the wall of the zinc sulfide which is inside the glass, and so the tube light is able to give the very large amount of light as compared to ordinary bulb. So this is all about the this experimental details of the Rutherford experiment. Now we'll next see about the what is the reason behind this. Now coming to the reason behind the three type of observations. So Rutherford says that the atoms are hollow ball-like structure, and he proposed the atomic model for the first time, and it is called as nuclear model of atom. So he said that atom is a hollow ball-like structure, and in the center there is a very small portion called as nucleus, and so he said that when the alpha rays like this they are passing, and so this type of observations he explained, and so it was there, and see how what happens. The passing of most of the alpha rays in a straight line like this. So see, it is clear from this diagram. These are nothing but these are the alpha rays. Alpha rays are nothing but the helium nucleus carrying 2 in positive charge, and this is the actually the internal structure of the this gold foil. The gold foil is made up of atoms, and so see, large number of alpha rays will pass in a straight line. Most alpha rays will pass a straight line because large space in the atom is empty. Now, so the conclusion part. So this is the conclusion. What was the conclusion? So large space is empty. As a result, alpha rays in large number were passed in a straight line. So the passing of alpha is undeflected in a straight line without going any deflection is due to the presence of large space. Space is empty. Space is empty, and the alpha rays were passed in a straight line. So this is the first point. Now, some alpha rays were passing by the nucleus, and it was established that nucleus is positively charged and alpha rays are positively charged. So when the similar charge are there, there is the repulsion. So the alpha rays which were going around the nucleus, they were deflected to certain angle. So it was there. So deflection of few alpha rays by certain angles is due to the passing close to nucleus. So it was the repulsive forces. So they were passing close to nucleus, and so they were deflected to certain angles. Now the third point, the bouncing back of 1 in 20,000, because the alpha rays which was going just straight to the nucleus was bounced back, because nucleus is massive and the mass of an atom is due to the presence of nucleus. So the bouncing back of 1 in 20,000 alpha rays is due to the heavy mass of nucleus. The mass of atom is concentrated in the nucleus. So this is there. So on this basis, Rutherford proposed the atomic model, and it is the nuclear models. And so see here, like this. And so the nucleus, this is the nucleus, and these are the orbits. Orbits are circular paths. So it said that the mass of an atom is concentrated in the nucleus, and nucleus has the protons and neutrons. And so around the nucleus there are circular paths called as orbits. So this is all about the Rutherford's atomic model.